I will begin with a word of prayer. Oh, yeah, thanks. What was the,
It was like a,
I'm afraid
Google Docs application.
it was a what?
It was like a Google Docs.
As a Google Doc, it's like so the QR code takes you to an application form?
They spent a lot of time on that one.
I have. Is it worth my time to fill out an application? I don't know, but
No.
just for kicks, you know. Anyway, let's pray. Dearly Father, we thank you for this day. I thank you for these students, for the beautiful weather outside. Just ask that you'd be glorified in what we do. Help us to understand a little bit more about your creation together this day, Lord. In your name I pray, Lord Jesus. Amen. Okay, so we're solving systems of equations, yeah? So let's talk about systems of linear equations. So let me just say, more generically speaking, you could have something like, let's say, A1, well, let me write it out for three equations. You could have A11 x, I'll write it, let me just write it in general. A11 x1 plus A12 x2 plus dot 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 plus A1n xn, and then you've got A12 x1, excuse me, A21 x1 plus A2, good grief, A22 x2 plus dot 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 plus A2n xn, and this goes on. Eventually you get to AM1 x1 plus AM2 x2 plus AM n xn. The first one is equal to B1, the second one's equal to B2, the third one's equal, rather the mth one is equal to B sub m. A solution is x1, x2, dot 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 xn that makes all m equations true. All right, so like last time I stated this in terms of, you know, just letters with x and y, right? But here's the general story. This would be what we mean by m as in mommy, linear equations, in n as in nanu, unknowns. How do you solve these, all right? Like, you don't know? Well, the good news is for us, we're pretty much going to focus our attention on m equals to n equals to either 2 or 3. All right, so like for us, we're just mostly looking at either 2 or 3 equations in 2 or 3 unknowns. All right, so, but anyway, just to get this out of my system, that's what a system of linear equation looks like in general. And if you want to learn how to solve these, you can take Math 221 or later Math 321. We talk about how to solve these in depth. All right. Okay, so let me just get into the examples here. So, well, before I get to that, there's 2 strategies. Let's not call them strategies. Let's call them techniques. Techniques to solve. All right. So, the one technique is called substitution. I would say that the other technique we could call elimination. Although the elimination technique, so substitution, I sometimes refer to as solve and substitute. That's kind of the steps involved, solve and substitute. Whereas elimination is, say, adding or subtract equations with intent to eliminate variables. So let me show you an example of all these things, yeah? So example 1. This one's really dumb. All right, so suppose I've got x plus y equals to 1, and I've got x plus y equals to 0. This is a good problem for elimination. See, because in this problem, I can subtract these equations. And what do? What happens if I subtract the equations? I get 0 on the left-hand side, and I get 1 on the right-hand side. So what's the answer here? So this implies the system is inconsistent. Inconsistent. So solution set is the empty set. It's the set containing no elements, all right? Talked about it last class. I said if you were to graph this, they would be parallel lines. There's no point of intersection, yeah? Let's look at another one. What if I had, oh, I don't know, x minus y equals to 1, and x plus y equals to 7, right? So I'm going to focus here on elimination method here for a bit, okay? Elimination. What would be the right approach here? If I'm going to use the elimination method, it's really nice here because I can add these equations, right? I add the equations, which, and what I mean by that is I add both sides. So when I add the left-hand side, what happens? See what happens? The y and the minus y, and we get 2x equals to 8. So elimination is really the right way to go for this problem. And then I get what? X equals 2, 8 over 2, which is 4, right? Then how do I find y? Go back to one of the other original equations, right? Which one? It doesn't matter, right? So we could go to, so we got 4 plus y equals to 7, which tells me that y equals 2. 7 minus 4, right? Which is 3. So my solution is 4, 3. Let's look at another one. I'll make this one a little bit more annoying for like the elimination method. Something like this. 2x plus 7y equals to 13, and x minus y equals to 2. So this one, it probably would be smarter to solve this one using the method of substitution, right? Whatever that means. But just for the sake of illustration, I want to show you how we would solve this by the method of elimination. So the method of elimination, there's a couple different tools in the toolkit. So we'll call this equation 1, and we'll call this equation 2, right? So if I look at 2 times equation 2, what's that give me? I get 2x minus 2y equals to 4. See what I did? I just multiply equation 2 by 2. All right? Now, I'm going to rewrite equation 1 down here. 2x plus 7y equals to 13. Here's equation 1 again. Right? Now what can I do? I want to eliminate. This is the method of elimination. So basically, the reason I multiplied equation 2 by 2 is to make them match up. See, now I've got the x's matching up, right? So to eliminate those, last time I added, right, to make the y's cancel. Oh, thank you. Oh.
Yes.
Wait a minute. Yes, there's been a disturbance in the force. Yes, sir. Thank you.
How come you didn't multiply by negative 2?
Oh, you could do that, but I didn't. So with this in mind, You're right. If I multiply by minus 2, I'd be adding right now. But since I didn't, I subtract. So subtract, the two x's cancel, and you get minus 2 minus 7, which is minus 9y. 4 minus 13 is what? Minus 9. Right? And so y equals 2, y equals to 1. Now you're absolutely right. I could have multiplied by minus 2, and that would have made that step an addition rather than a subtraction. You know, there's more than one way to do it, is what my larger point here. Now how do I find x? Yeah, which equation should I use to find x, do you guys think? It's all good. I'll just come back here.
I'll use the second one.
What's that?
I'll use the second one.
Use the second. Yeah, I think use the second one. That's the smarter move here. So the second equation 2 tells me that x is equal to 2 plus y if I just adjust it a little bit, right? So that's equal to 2 plus 1, which is 3. So my solution is 3, 1. All right. Now this one I think actually would have been like easier if we used the method of substitution, right? So let's work example 3 again, but with substitution. So I've got 2x plus 7y equals to 13. I've got x minus y equals to 2. So I'm going to call this equation 1, call this equation 2. So I solve 2 to obtain y equals to, x minus 2. Right? Then I can plug that into the other equation, right? Then substitute y equals x minus 2 into 1, which gives us 2x plus 7 times x minus 2 equals to 13, right? And then what? Then we work that out, right? So both the method of substitution and the method of elimination, the goal, the name of the game here is to reduce the number of variables, right? We want to go from 2 variables back to 1 variable, because once we're to 1 variable, we can solve that thing, right? It's not a big deal. Like, we just multiply it out, right? What you got? You got yourself a 9x minus 14 equals to 13, which gives me 9x equals to 27, which is x is equal to 27 over 3, which is, 27 over 9, which is 3. And then I have to go and, well, what's y? Y is x minus 2, right? Which is 3 minus 2, which is 1. So therefore, 3 comma 1 is solution. Which, of course, is what we just found the other way, right? Yeah.
Now, see that you do plugging the second one using y.
Yeah.
It's easier, but could you have used x?
Oh, absolutely. We could have solved for x and plugged in. What would have happened if we did that? If we plugged x in to the other equation, then we would have one equation and one unknown in y. We would have found the y first. So yeah, I mean, like, there are, dozens of ways to do these. Absolutely. All right, so let me see here if I can find a problem here. Here, I've got one in my, and I'll let you guys pick. Well, it says to solve by substitution, so I guess, listen, your homework has instructions like solve by substitution or solve by method of elimination. We can't tell. I can't tell whether you're using one method or the other, right, in the homework. And, I don't think that's something I'm going to, like, fuss about on the quiz or the test. Like, I'm not going to force you to use substitution or elimination necessarily. I don't think that's something I need to do. The point is you need to have a method to solve systems of equations. And you should be comfortable with both. I mean, I don't know if I can design a problem which you can you necessarily get wrong if you don't know elimination versus you don't know substitution. Like, I don't know. That's actually kind of an interesting question. Is it possible to make a homework problem, besides just saying, use the method of substitution and like forcing you to do it, right? Is there a problem through the logical content of the problem that forces you to use, you know, the adding equations versus the substitution way? I don't know. Let me stop debating about potential questions and let's solve this system. So we've got minus 2x equals to 8y plus 18, and we've got minus 33 equals to 7y minus 4x. So what's the difference here between this example and the ones we've worked up to this point? Yeah, the x is on the different side than the y. They're not in what I would call standard form, right? The thing I wrote at the start of class, that's the standard form for m equations and n unknowns, all right? Now, I'll come back to that and make a comment about how to solve that with technology here in just a little bit, but because I think you should at least be, I mean, I won't test on it, but for your information, I should tell you something about that, because there's something quick I could say that would be perhaps helpful to you. Anyway, this one here, what do you guys think we should do? Substitute. Which one do you want to? So let me call this equation 1. Let me call this equation 2. So which one do you want to use? Solve 2 for which one? For y? All right. So we've got 7y is equal to 4x minus 33, right? Which means y is equal to 1/7 of 4x minus 33. So there you go. This one I felt like I need to show a step here because it's a little bit complicated, right? So there you go. That's y. Now what do I do with that? So this is important. You must plug it into the other equation. Don't be like me. When I was learning this stuff, I would just solve for one, I would ignore what I was doing, and then I would plug it back into the same equation. You know what happens when you plug this back into the same equation? You ever try it? What happens if we plug what we solved for back into equation 2 again? Let's try it out. Let's see what happens. This will not be productive, but let's see what happens. Minus 33 is equal to 7 times 1/7 4x minus 33 minus 4x. What happens? The 1/7 and the 7 cancel, right? You get 4x minus 33 minus 4x, which is equal to minus 33. Minus 33 is equal to minus 33. What does this mean? What's that? I mean, this is true. It's true, right? But it's useless. So this is what happens if you don't plug it into the other equation. If you plug it back into the equation you just solved for, you accomplish nothing. You'll just get a tautology, an equation which is automatically true. All right? So that's why we must plug it into the other equation. Otherwise, this happens to us. All right? So if you come back to 0 equals 0, there's a chance that you did what I just did. All right? So you must use both equations. So let's use the other equation. The other equation is what? Minus 2x equals 8 times 1/7 times 4x minus 33 plus 18. There's a fraction, right? How do you eliminate fractions to make the math work out nicer? I think the smart move here is to multiply the whole equation by 7. If I multiply the equation by 7, I get rid of the 7th, you know? So multiplying by 7, I get minus 14x is equal to 8 times 4x minus 33 plus 7 times 18, whatever that is. Well, I mean, it's 70 plus 56, so it's 126, I suppose. So what we got here is minus 14x plus, excuse me, minus 14x is equal to 32x minus 8 times 33, which is 240 plus another 24, minus 266, plus I think I said 126, was it? I guess I could get my calculator out. I'm starting to feel a little bit antsy about my numbers. Yeah, see, for example, that wasn't 266, that was 264, my bad. There we go. Okay, so 264, 126 minus 264 is 138. So I've got minus 14x minus 32x equals to minus 138. What's 14 and 32? That's 46. So I've got minus 46x equals to minus 138. So what's x equal to? Three. Minus 138 divided by minus 46 is 3. That was unexpected, wasn't it? Yeah? 3. And what's y equal to? 1/7 of 4 times 3 minus 33, which is what? That's 1/7 of 12 minus, what's 12 minus 33? It's negative 21, which is minus 3. So the solution here we found the solution is, in fact, 3 minus 3. That is an ugly looking problem to have such a nice answer, isn't it? I mean, man, the steps here they're really kind of ugly, weren't they? I bet this one would be easier if we had used elimination. What's that? Did I lose you guys at this down here? That's just 138 divided by 46 is 3. What's that?
Where did you get 14x from? The first line written in red?
Oh, to go from here to here? I multiplied the equation by 7 because I didn't want to deal with the fractions. So let's take another stab at this problem as a means of understanding maybe why elimination's a better method sometimes. Maybe, I don't know, like this is fine. This is a totally legitimate way to do it. And this problem might be just as difficult in the other way, but let me try it again. So, and like the first thing I'm going to do is I'm going to clean things up. All right, and what I mean by that is I'm going to like reorder the equation so that it's in standard form. So I'm going to take this and I'm going to trade it for, minus 2x minus 8y equals to 18, and minus 4x plus 7y equals to minus 33, okay? So what I did was I just took equation 1 and equation 2 and I flipped things around and put them in order, all right? Just rewrote the equations so that they're nice and tidy in standard form, okay? Are you guys with me so far? Now the next thing I'm going to do is I'm going to, let's see here. You wanted me to multiply by minus 2, the earlier problem. I'm going to do it now. So let's multiply equation 1 by minus 2. Multiply by minus 2. That gives me 4x plus 16y 2 times 18 is what? 36, yeah? So by multiplying that by minus 2, I made it so that when we add these equations, the x's are going to cancel, right? So the method of elimination here, add these equations, my x's are canceling, and I've got myself a 16 plus 7, which is 23y, equal to, really? 3. Is that right? Uh-oh. Uh-oh. Whoa. Whoa. Uh-oh. Uh-oh. I think I made a mistake. Because when I add those, I get 3. And y is definitely not 3 over 23. Where's my mistake? Can you guys find it? Was it in the rewriting of the equations? Did I copy the equations down faithfully?
Why didn't you just,
Wait, wait.
the initial?
What? Shouldn't it be negative 18?
Well, I subtracted 8y to the other side.
But you could have also added the 2 to one side, the 2x, and then subtracted the 8. So negative 18 is 8y plus 2, and then
So you found one that doesn't want
Yeah, it should be negative 36.
Negative 36? Oh, yes, thank you. Because I multiplied by
a negative.
minus 2, right? So you can't do it just minuses on one side, not on the other. That's totally bogus. And with that, we get minus 69, and then everything is right in the world because y is minus 69 over 23, also known as minus 3. And how do I find x? Pick your poison, right? So like minus 2x minus 8 times minus 3 equals to 18, which gives me minus 2x is equal to 18 plus 24, minus 24 rather, which gives me minus 2x equals to minus 6, which gives me x is equal to 3. So I do think this problem is easier with elimination if you have a mastery of elimination, if you understand the method of elimination. This one is easier to do with elimination. All right. So I would say, just as a generic comment, the method of elimination is a better method overall. The method of elimination is much closer to what we teach in linear algebra, which is called row reduction. I don't think we do row reduction in here. Remind myself. Yeah. All right, so do you guys feel like you can do 2 equations and 2 unknowns? I'm gonna move on to 3 equations and 3 unknowns because I think that's what you need me to spend more time on, right? Yeah. So let's go on to 3. We can come if you guys have questions about 2 equations and 2 unknowns, like Friday or when we come back. Although not when we come back, because what are we doing when we come back from break?
Quiz.
A quiz. Woohoo! Day 1, yes.
And a test on day 3. Yeah, Monday is the quiz, and then Friday is the test.
That is true.
Guys, let's think about this for a second. You don't have to do that. There's other options.
There really aren't, though, because the other option is we could move the quiz to Friday this week.
Or we could move it to Wednesday, but we don't really
I won't be here on Monday.
I actually don't mind that.
So some of you actually want to take the quiz this Friday?
No, think
Who's gonna
about it.
vote?
Precisely.
We might forget some stuff over the break.
See, I don't think I can do the quiz Friday because I publish solutions to the quiz, and then that makes it very awkward because then I got the people who've taken the quiz and are looking at the solutions, and we got the other people who are like saying they're not going to look at them, but they really should be looking. It's just not good. The quiz is on Monday, so if for some reason you are unable to come to the quiz on Monday, you can come to the quiz on Tuesday morning at 8 a.m. in my other section. Yeah. There is no online quiz. Get out. All right, so sorry. Excuse me. Study guide. Every day is a study guide. Every day. Let's see here. So example 6.
At least I know now that there's going to be a quiz the Monday we come back.
All of the quizzes and tests are in the course planner. They have been available since the first announcement in Canvas. They've been there. It's always been there.
Happy Thanksgiving to you, too.
Well, if you already understand everything in here, then you're good to go anyway,
I'm
right?
getting this stuff. I'm glad I am.
That's good. So I think the best course of action would be to, finish the homework over break. And that way you'll be more or less ready for the quiz. And there's always about, 20% bonus on the quiz. So you just take it, do your best, and then you'll find out what you don't know and adjust. And hopefully Friday of week after Thanksgiving, you'll get it 100%, right?
Sir.
How do we solve this? So see, we've got 3 equations and 3 unknowns. So we're basically going to play the same game we did before, but now we may have to be content to reduce it to 2 equations and 2 unknowns as like an in-between step, all right? So I'm just going to teach elimination for these kind of problems because I think elimination's the better method, so I'm going to focus my attention on that. 1, 2, 3. All right, so elimination. The idea of elimination is to look at the equations and see if there's a pair that you could add or subtract or something to eliminate variables, right? So let me look at it this way. If I take equations, if I take equation 1 plus equation 2, what does that give me? And if I take equation 2 plus equation 3, what's that give me? So look at this. 1 plus 2 gives me 3x plus 2y. The z's cancel, and we get minus 3. All right? And also equation 2 plus equation 3. If I add those two, I get 3x. Oh, the y's and the z's cancel. What an embarrassment of riches. So that gives me 15. So I didn't know that was going to happen. That's like, man, this one's easy. Golly, this problem's too easy. Oh well, it is what it is. So this says x equals 2? 5. And then what's y equal to? We can use this one here, right? So 2y is minus 3 minus 3x. So y is 1/2 of minus 3 minus 3x, but x was what? It was 5, right? So y apparently is, how did I get what? I added equation 2 and 3. So 3x, those cancel. 15 minus, oh, that's a good question. I made a mistake, this is a quick answer. Follow man, let's see here, 9. So x is equal to 3, thank you. And so that puts a 3 here. Sorry, I'm just so emotional today with Trump making his announcement that he's running again. It's hard to contain it. Let's see here. Although I don't know, I must say, I looked at news, and I expected it because he said he was going to on the show I listened to a week ago. But it's not even in the news aggregator I was looking at. It wasn't high on the list. I'm like, what? Anyway. Are you getting me back on track? Is that to get me back on track?
Yes.
Oh, interesting.
I love substitution and I love all this stuff.
Wait, I have a question.
Mm-hmm.
Why didn't you do 1 and 3?
Why didn't I do? I mean, you have many choices. You have many choices, like here.
It doesn't matter if you do 1 and 3, though?
Well, I mean, it matters. Everything matters in terms of your choices here, but it's like choose your own adventure. Different adventures are going to take you longer. Some adventures go nowhere. Anyway, so this here is what? We've got minus 3 minus 9, so I think it's a minus 12. Minus 12 over 2 is what? Negative 6, all right. Now how do I find z? You can use any of the three equations you want. You can't go wrong, right? Let's use equation 1. Yeah, so we have x plus y plus z equals to 3. Let me plug in what I know. 3 minus 6 plus z equals 3. So that means the 3's cancel, and we get z equals to 6. So my solution, thank you. Solution is 3 minus 6, 6. That's the solution. Yeah, well, you have to write the triple gets written x, y, z. That's the rule.
So if it
Yeah.
were like A, G, and F, you would just write it in alphabetical.
If you had a system of equations in A, G, and F, that'd be weird.
Yeah, but I mean, if it happened, what would you do?
I would rewrite A, G, and F as x, y, and z, as to not confuse the students is what I would do. I have to let the students have fun? Oh, I don't know about that. I don't know about that. Did I ever move the camera?
I don't.
I'm my own worst cameraman, you know? Yeah, we're good. Okay, let's work another. This one worked out too easy, guys. I need one that's got more annoyance. Like the fact that this worked out to 3x equals to 9 is a fortuitous event for us. Usually, you have to solve two equations and two unknowns when you get to that step there. So let's see if the next one works out uglier. Here I've got 4x plus 3y plus z equals minus 17. And I've got x minus 3y plus 2z equals to minus 4. And I've got 11x minus 2y plus 3z equals to minus 37. All right, so let's use the method of elimination to solve these, okay? So this is equation, I'll call it 1, I'll call it 2, I'll call it 3. You can use Roman enumeration if you want. You can use regular numbers. I just, whatever, but yeah. How about this? Do you see any, here's, so I look for patterns. I look for things that are nice in terms of canceling things out, right? So what jumps out at me as I look at this is that there's like look at this right here, right? Those are the same but different, like off by a sign. So if I add the equations 1 and 2, the y is going to be eliminated, right?
Yes.
5x plus 3z.
Yeah, so what's that? So, okay, so equation 1 plus 2, that gives me 5x plus 3z equals to negative 21. All right? So that's very nice. You know what I'm going to do here? I'm going to use a combination of elimination and substitution. All right? So that's elimination, what I just did, because I've eliminated y by adding equations, right? So remember what I said about that previous example? We have to use the other equation. That's really easy when you have two equations and two unknowns, right? If you solve equation 1, you got to use equation 2, right? But that logic still is true here. So like to solve the equation, to solve the system, we have to make use of all the equations, right? So think about this. I just used equations 1 and 2, and together they gave me this truth here, right? So to solve the system, I need to use 3, right? So what I want to do is I want to substitute this equation into 3. How do I do that? How do I substitute this new equation, let me call it Pac-Man, into equation 3? How about this? Oh, I can't quite do that, can I? Rats. If I do that, what happens? That doesn't actually help me because I'd still have, if I solve this for x, I'm still going to have a, oh, rats, that doesn't quite work. I was hoping that would work. Well, I guess I'm going to fall back on elimination again, if that's okay with you guys. What I'm going to do is I'm going to do 11 times equation 2 and see what that gives me. That gets me 11x minus 33y plus 22z equals to minus 44, right? Now that I've done that, I can stack that up against equation 3, right? Because equation 3 is 11x minus 2y plus 3z equals minus 37. And, oh man. Well, I mean, I did it. What happens when you subtract these? Minus 31y plus 19z, right, equals to, what's that, minus 7? All right, so that's, let me call that ghost. All right, so then what? So, So the question is, what variable we want to work our way to one equation and one unknown, right? Can you guys see a path to one equation and one unknown through all this? How about, oh man, well I got a minute. There's no way I can do this in a minute. So what I would do, guys, is this. Let me just say it in words for you. We can solve the Pac-Man equation for z equals to like a function of x, right? We can solve for z as a formula for x here, all right? Then I can take that and I can plug it into this z. That will give me y in terms of x, all right? Then I have z in terms of x, I have y in terms of x, and then I can go back to any three of the equations and put that in, and I'll have equation just in x. So this is what you have to do. Like solve this one for x, plug it into here, that gives you y as a function of x. Then you take that and you plug it into one of those. Anyway, see you guys Friday, unless I don't. In which case, have a good break.